we're looking at something called a self-induction. So what does the word induce mean? We use the adjective induced to describe those EMF and current which is caused by changing magnetic field. So whenever we change the magnetic field around a conductor, we have the voltage induced across that. Array, just a second. Now it's right. Why is the word self over there? Let's have a look at that. We have a normal circuit. We are switching it on. What happens? Current will flow. So because of the current, what happens? There is magnetic field. And say this is current I, and say this is BI. Magnetic field because of the current. Should use some other color. Because of current. Okay, guys. So next, the question is, what was before switching on? Before it, when it was off, and when it got on, what happened to the magnetic field? The magnetic field was 0, and here it is positive. So what does this mean? This means there's change in magnetic field, which is non-zero. Basically, there is change in magnetic field. And what does this lead to? Yes, induction. Right? So a current will be induced in what direction? In opposite direction. So this is your induced current. Induced current. Of course, current per se will not be flowing like that, but the rate at which the current will flow, it will be a bit lesser because of the induced current. There will be opposition to actual current. If you are able to draw it, the induced current will be in this direction. So basically opposing the cause. When we switch it on, this is when it's just got on. Okay. When this happens, there is an opposing actual current. And that's why the word self-induction, it is because of itself, right? We have a magnetic field which will oppose it. So for opposing it, as per a right hand rule, the current has to be down. If you use a right hand thumb rule over here, the current has to be down because the opposing magnetic field will be, in this case, clockwise. This is anti-clockwise, right? So that's how the direction would be. And this is known as self-induction. When you try to change the flow of water, you create ripple, right? This ripple can affect the flow of water itself, creating a feedback loop. Similar to that, in a similar line, we can think of it. Okay, now let's look at the actual definition. I've again used some other way to explain this. Fact 1. We know that any change in magnetic field experienced by a wire or a loop of wire induces a opposing effect. That we know. Flowing current produces a magnetic field. This also we know. So combining these two facts, we have a concluding point. Combining the two facts, if there is any change in the amount of current in the wire, it will lead to a change in magnetic field strength. This change will expose the wire to a varying magnetic field, resulting in an induced current that opposes the change. This is what you guys have to write in your exam. So an example over here is, what do we have? We have a coil and we have the current flowing in this way, right? So if I use my right hand thumb rule, magnetic field, so this will be north, that will be south. So how will the induced field look like? This will be south and that will be north, right? Opposing. So it has to be opposite direction. So basically your induced current will be in the opposite direction in this way. That's your Lenz's law EMF. Because it will try to oppose the increase, right? Increasing current. If the current is reducing, it's in the same direction, okay? Just that it's reducing. What will happen? It will try to not let it reduce. So it will contribute in the same direction. Okay, so that's your Lenz's law EMF for this particular scenario. It's simple. Whatever it might be the scenario, it doesn't want it to change. It's not that it hates something over here. What it doesn't want is change. If there is X amount of current going through it, it wants that X amount of current going through it. If it reduces, it will give more. If it increases, it will try to take it. It will try to oppose. As simple as that. Okay, now finally the definition. Self-induction is the phenomena where a changing electrical current in a coil induces an electromagnetic force in the same coil. So the same coil is important over here. Why it happens? It occurs because of the changing current creating a varying magnetic field, which in turn induces a voltage opposing the change in current, according to Lenz's law. Okay, so all in all, this is what you guys have to write. We need to draw the graph. Just let me take a second. So let's get one more perspective. Now, we have current versus time graph. So that's your, right? That's your maximum current. Now, over here, what it does is the induced current, it will try to oppose it. So your induced current might look like this. Till what point? Till this is happening. Okay, actually that's a lot of current. That's not practical. That's a bit more practical. Okay, it's not perpendicular. That's better. Not exact, but better. So this would be your induced current. So this is your position or opposing. Okay, opposing current. We'll write that. This is opposing flow of current. Okay, guys. Now here there is no change. So no change. So the current will be nothing over here. Right? That is opposing current. But here, what will happen? There is decreasing current, is it not? There is decreasing current. So what will happen over here? It will try to contribute from its end, and there is some current that will be contributed in this way. So this will opposing stoppage of current. All in all, this is what we're looking at. Either it will try to decrease or increase. Okay, so when there is no change, there is no induced anything. Again, this is just a rough view, a lot of details that we are not talking about. So we know that induction is a phenomena when we have a conductor exposed to a changing magnetic field. We are inducing EMF or current across it, right? And the current will flow through the entire circuit. Now, when we have a circuit and there is change in current through it, there will be change in magnetic field because flow of current produces magnetic field around it. That we know for a fact. So when this is happening, is it not possible that we have a magnetic field, changing magnetic field? Can it lead to induced current? It does. and a wire doing it to itself is your self-induction, right? So this can be explained with all of this concept. Again, this is for entirely for explanation. Depending on the question, please make use of it. As a definition, the definition is over here. And the graph, everything is there. It's scattered. Depending on what you guys need, you guys can, it's like a Lego set. Parts are there, you adjust it as and when it's needed. Okay, so you can pause and have a look.